Good morning, my dear students. Welcome to lecture 5 of module 4. Now, in this lecture, we will discuss the projectile motion. So, what is meant by projectile motion? Projectile motion is a curvilinear motion in which the body is given an initial velocity at a particular angle, and later it is acted upon by only the gravitational force, or acceleration due to gravity is the only component acting on the body. Okay, so for the motion of the body only initial velocity is provided, later the motion is provided or governed by the gravity. Okay, so it's the motion of a body that has given some initial velocity and subject to acceleration, which is due to gravity alone during the subsequent motion, and that kind of motion is called projectile motion. It's a good example of a curvilinear motion. Okay, now we will take a few example of projectile motion. One is the motion of a basketball. It is a projectile motion, and the motion of a cannonball is again a projectile motion. Okay, now we will take general projectile motion. Okay, in xy, we are taking plane projectile motion in xy plane. Okay, so xy axis at origin O, and at the origin the projectile, the body which undergo projectile motion is called projectile. Okay, so the projectile start from O, and we are giving a initial velocity to the body u. Okay, then that u is at an angle theta with the x-axis. Okay, so it is given an initial velocity u and it is at an angle theta with the x-axis. So that theta is called angle of projectile. Angle of projectile is the angle made by the initial velocity with the x-axis or horizontal axis. Now this u has two components. Remember, u is only the initial velocity. So what will be x component? U cos theta, and y component will be u sin theta, right? Now the projectile reaches a peak point. It is represented by P in that curve, and the distance from the horizontal point or the x-axis to the peak point is called height of projectile. Okay, this h is the maximum y distance of the projectile motion, right? So that maximum y distance is called height of the projectile motion, and the distance and the projectile starting from O will reach a maximum peak point at P, and will hit the ground or hit the same horizontal level of O at the point Q, right? You can see at the point Q it hit the same horizontal level of O or origin. So the distance from O to Q is called the range of projectile, represented by capital R. Okay, now this red curve is called trajectory of projectile. Now later we will prove that, we will show the trajectory of a projectile is a parabolic trajectory. It's parabolic. Okay, now you should remember the projectile motion is a combination of x-axis motion and y-axis motion. Okay, it is a 2D motion. It is the superposition, or you can say like it is a superposition of x axis motion and y-axis motion. Okay, so these are the normal terminologies used in a projectile. Now we will take the equation of path followed by the projectile, which is the equation of trajectory of a projectile. Now I will redraw the projectile motion here. So x and y axis, the red curve represents the projectile motion, and we are given an initial velocity u, and it has u cos theta and u sin theta components. Now you should remember the velocity at any point on the trajectory is the tangent at that point. Okay, so u is actually the tangent of the trajectory at the origin, at the point origin. Okay, at any point you can draw the velocity, and you can have this if you know the angle theta with respect to x-axis, you can find out u cos theta and u sin theta. Now remember, this theta will change. Okay, as long as the u, the direction of u, not only u, the direction of velocity changes, this theta also changes, right? Now it is only u, initial velocity is u. Now the only force acting on a projectile is the gravitational force, okay, which is acting in the vertical direction or y direction. So the only acceleration acting on the projectile is ay. Only acceleration acting on the projectile is in the vertical direction, which is ay, that is equal to g. There is no force acting in the x direction on the projectile. Since there is no force in the x direction, means fx equal to max, fx equal to 0, so ax equal to 0. So there is no force acting in the x direction. Only force acting on the projectile is in the y direction. So since there is no force acting on the x direction, ax equal to 0. So what do you mean by ax equal to 0? Ax equal to 0 means there is no velocity change in the x direction, right? If there is velocity change, then only there is acceleration. So there is no velocity change in the x direction, or the x component of velocity of the projectile, which is u cos theta, remains constant for the entire motion of the projectile. So that since x equal to 0, vx means x component of velocity at any point. Okay, it is not ux, vx, which is always u cos theta, which is constant, right? So if you take any point on the projectile, you can draw the velocity, and if you split that velocity into x component and y component, the x component is always u cos theta, where u is the initial velocity. Y component will be different. Y component, we should know the velocity at that point and angle with with respect to x axis. Okay. Now for a projectile, the x direction motion is uniform velocity motion since x equal to 0. But y direction motion is not uniform velocity motion, it is uniform acceleration motion. Now since for the for the projectile, from starting from origin to the peak point, the body is moving the upward direction and acceleration is in the opposite direction, right? So since I discussed in the previous case, the direction in which body moves, that's the positive direction, so acceleration is acting in the negative direction. That's why I put minus g. Okay, so in the y direction it is uniform acceleration motion. Now I am taking x direction motion and y direction motion, and let t is the time taken by the projectile to reach a particular point on the trajectory. Okay, now if you take the x direction motion, x is equal to vx into t. Why? Because ax equal to 0, so we can use velocity equal to displacement by time, and displacement is velocity into time. Velocity in x direction is vx, displacement in x direction is small x, right? So small x is equal to vx into t. Vx is always constant, which is u cos theta into t. Clear? That is equation 1. Now go to the equation. If you take the y direction motion, we can always use that as the three equations. So when you are using the three equations, as we studied in the kinematics of rectilinear translation. So v equal to u plus at, s is equal to ut plus half it square, v square equal to u square plus 2s. Now if when you are using for a curvilinear or a 2D motion, you have to replace like vx equal to ux plus ax t, like that. Okay, so I am using s is equal to ut plus half it square here. Now s in y direction is sy, or simply y, small y equal to uyt plus half ayt square. Okay, half ayt square, that is y. Now what is uy? Uy is simply u sin theta. So u sin theta t minus what is ay? Ay is minus g, so minus gt square, right? Now if I rearrange from equation 1, if I find out t, it will be x by u cos theta, right? So equation 1, you will get t as x by u cos theta. Now if you substitute this t in equation, 2, or substitute equation 3 in equation 2, what I will get? Y equal to u sin theta into t. I am replacing with x by u cos theta. Again I am replacing t square with x by u cos theta all square. Now if I rearrange that term, u get cancelled, sin theta by cos theta is tan theta, x remains, and here I am taking g by 2 u square cos square theta x square, right? So that is the equation of trajectory of a projectile motion. Now if you closely look at the equation 4, for a particular projectile, u initial velocity is constant. For particular projectile, it is always a projectile is represented or specified by its initial velocity and the angle of projectile, sorry, angle of projectile theta. So for a particular projectile, that u and theta is constant. So since u and theta is constant, the term in the bracket, that is tan theta, is constant, right? So and term in the second bracket, g is constant, u is constant, theta is constant, so cos theta is constant. So the terms in the bracket for a particular projectile motion is constant. The only variables are y and x, right? So I can replace this equation like in the form of, like equation 4 is in the form of y equal to ax plus bx square, right? Now the equation y equal to ax plus bx square is the standard equation of a parabola. Okay, so which represent the equation of a parabola. So what it means, which means the trajectory of a projectile motion, which is the equation 4, is a parabola. Okay, so that's the proof of trajectory of a projectile motion is parabola. Okay, now at a particular point, okay, this thing I already explained. Okay, this point you should is very important. Look at the graph. At a particular point, the velocity is represented by that black arrow. Velocity is v. Okay, now it will make an angle phi with the x-axis. It need not be the theta. Okay, it make an angle phi with the x-axis. So you had x component will be v cos phi, y component will be v sin phi. Now how v cos phi equal to u cos theta? Because the x component of velocity is always u cos theta. That's why I put u cos theta there. Got it? So you should remember v cos phi equal to u cos theta, or remember like this: at any point on the projectile motion, the x component of velocity is always u cos theta. Y component, the y component, it related to velocity at that point and angle phi. Okay, now what will be v? V will be root of vx square plus vy square. Vx is u cos theta all square plus v sin phi the whole square. Clear? You should remember this also. Is very important for doing the or solving the problem. Okay, now we will go to the equation of time of flight, range, and maximum height of a projectile motion. Okay, now what do you mean by time of flight? I will again redraw the projectile motion. Here we had u cos theta, u sin theta, and ay is g, and you should remember that point a. A is the peak point, and from x-axis to the peak point is the maximum height, and O to B is the range. Now if you closely look at the point A, what will be the direction of velocity at that point A? It is the tangent at that point A. Now what will be the direction of tangent at the point A? It will be horizontal direction, right? Okay, before going to that, what is time of flight? Time of flight means the total time taken by the projectile to reach from O to B, O to A to B. Okay, that is time of flight. Time of flight is the time taken by the projectile to reach from O to B. Now the time of ascent means time taken from the projectile from origin to the peak point A. That is called O to A is the time of ascent, and time of descent is time taken from A to B. Now if you closely look at that curve, O to A time and A to B time both are same. Okay, so that time O to A time is called half time or represented by T by 2. The total time is capital T, time of flight. Time of ascent equal to time of descent, okay, which is T by 2. So O to A is T by 2, A to B is again next to T by 2. Now if you consider the motion from O to A in y direction, you can consider the motion from O to A in x direction and in y direction. Okay, I am considering the motion of O to A in y direction. Now at the point A, Vx is always u cos theta, Vy is 0. Why? Because at the point A the velocity is tangent at that point A is horizontal, right? If you closely look at that figure, the tangent at the point A is horizontal only. Got it? So since it is horizontal, it does not have any vertical components, or Vy equal to 0. Vx is always u cos theta. Now for a motion from O to A, initial velocity is small u and final velocity is v. Okay, now that v has component Vx and Vy, since v equal to Vx is equal to u cos theta, u has component u cos theta and u sin theta. Got it? Now I am taking the motion in y direction from O to A. So v equal to u plus at I am using, since y direction motion, so Vy equal to uy a by t. Okay, you should clearly understand or clearly familiar with this kind of approach. So v equal to u plus at you can use here, but you should put Vy equal to uy a plus a by t if you are taking y direction. Now what is Vy here from O to A? Vy is 0, right? 0 equal to what is uy? Uy is u sin theta. What is ay in this case? Ay is minus g, right? So 0 equal to u sin theta minus g. Ay is g. Small t, what is t? O to A, the time taken is half of the time of flight, so I am putting t by 2. Now if I rearrange this term, I will get u sin theta equal to g into t by 2, right? Then I will get the equation for time of flight as t equal to 2u sin theta by g. So you should remember this equation. Even if you don't remember the derivation, you should remember the final equation of time of flight, which is 2u sin theta by g. Okay, it's very important for doing the problem. 2u sin theta by g is the time of flight, and for half time is u sin theta by g. Okay, now height h, the expression for h. For now again take the y direction motion, I am taking the next equation, v square equal to u square plus 2as. So vy square equal to uy square plus 2a by s. Now vy we already know 0, uy is u sin theta, we know, ay is g. What is s? S is the displacement in y direction. Okay, how much the displacement, the projectile moved from O to A in y direction? That is actually h, right? If you look at the motion from O to A, the displacement of the body in y direction is capital H, right? What will be the displacement in x direction? Which will be r by 2. Clear? Okay, so if you put the values here, you will get 0 equal to u sin theta all square minus 2gh, right? Now if you rearrange, 2gh equal to u sin theta all square, or h is equal to u sin theta all square divided by 2g. This is the equation for height. Okay, now the last equation, the equation for the range. Now for the equation of range, I should take the x direction motion to range, right? Because range is the displacement in x direction. So I am considering the motion in x direction. Now x direction motion, you should remember the x direction motion is uniform velocity motion, right? So x is equal to vx into t I can use, right? I don't have to consider the acceleration. Now for O to B motion, or for the entire projectile motion, O to B is the x displacement. O to B is r. Now what is vx? Vx is equal to u cos theta. And what is t? T for O to B motion, the t is the total time, right? So r equal to u cos theta into t, that is the equation for range. But again I am replacing t from the equation of time of flight in this equation. If I substitute the time of flight in this equation, I will get u cos theta into 2u sin theta by g, right? If I rearrange this equation, I will get two u's are there, so u square, u into u, not 2u, u into u square, 2 sin theta cos theta. 2 sin theta cos theta is actually sin 2 theta. So I will get range, equation of range as u square sin 2 theta by g. Now these equations are already actually you are studying these equations in the plus 2 itself, is there in the NCERT textbook. But again sometime they may ask this equation to derive in your case also, KTU or university may ask. But anyway, you should remember the final equation of this, final expression of this T, H and R. Now again one more thing, if you look at the equation of range, what will be the maximum value of range? So for a particular projectile motion, u is constant, right? So suppose you can change the angle theta for a particular projectile motion. Okay, you have the ability, or you have the provision to change the angle theta. For a particular u, what is the maximum value of r? So maximum value means sin 2 theta is 1, that is the maximum value, right? For a particular the value of theta for r is maximum for a particular u is sin 2 theta equal to 1. R is maximum when sin 2 theta equal to 1. When sin 2 theta equal to 1 means 2 theta equal to 90 degree, right? 2 theta 90 degree means theta equal to 45 degree. Okay. Now, which means for a particular projectile motion, if you want maximum range, you should project the body at 45 degree. Okay. So this thing is actually using in the javelin throw. Okay. Now that is the we discussed in the previous slide, we discussed the general projectile motion. Now we will here discuss the motion of a projectile thrown horizontally. Okay, now I am taking a projectile motion in xy direction where the projectile is horizontally, we are at a particular height, we are already had a particular height, and we are dropping the body horizontally. If you drop or project the body horizontally with the initial velocity u, the body will not go in the straight line motion because of acceleration due to gravity, it will undergo a projectile motion, right? So this also a projectile motion, it is of the off part of a previous general projectile motion, right? Now Ay is acting in g. Now the body is moving in the downward direction here, acceleration is also in the same direction, so here Ay you should take plus g. Okay, now ux is equal to u, uy equal to 0, right? And the range is r and height h. So time of flight, for the time of flight you take the motion in y direction, so I am using s is equal to ut plus half at square. So s in y direction is y and uyt plus half ayt square. So y is actually h, right? H, uy is 0, we know, 0 plus half gt square, or time of flight t equal to root 2 g, sorry, root 2 h by g, that is the time of flight. Okay, it's a very straightforward equation. Now if you if you want to find out the range, we have to take x is equal to vxt. X we know, x is r, and vx is equal to u, vx is equal to ux, right? Ux is equal to u and t is capital T. So u into root 2 h by g, t we already find out the expression, so you substitute here, you will get the equation for range. Okay, so this motion of projectile thrown horizontally is a very simple motion. You don't have to remember this equation. Actually you can simply use x direction motion, y direction motion, and you can simply solve the equation to find out t and r. Okay, now we will solve a few problems in the projectile motion. Okay, So first problem is, a projectile is fired with a velocity of 500 meter per second at an elevation of 30 degree. Find the velocity and direction of the projectile after 30 seconds of its firing. So the velocity given here is the initial velocity, and the elevation means the angle of projectile. Elevation means it is the angle with respect to x-axis. So u and theta is given. You need to find out the velocity and direction of projectile after 30 seconds. So what is the velocity of the projectile after t equal to 30 seconds? Okay, so I am drawing this projectile motion here, xy axis, and this is the projectile motion. So you had initial velocity u, it making an angle theta, u cos theta, u sin theta, and okay, so u equal to 500 meter per second and theta equal to 30 degree. Okay, now after t equal to 30 seconds, you need to find out the velocity. So you can simply find out ux is equal to 500 into cos 30, right? It will coming as 433.013 meter per second, and u will be 500 sin 30, which is 250 meter per second. Now after, let's say, after 30 seconds, the point the projectile is that point, and the velocity at that point is v. So it is making an angle phi. So you had vx and vy, right? Now what is vx? If you remember, vx is actually ux, it is not changing. So vx is equal to ux is equal to 433.013. now for vy is v sin phi, but we don't know the value of v or phi, so you cannot use vy equal to v sin phi here. Okay, you won't get vy if you use v sin phi, right? Because you don't know the angle and also the velocity v. Okay, for finding out vy, we are taking the projectile motion or the motion of the projectile in y direction. Okay, so in y direction you can use any of the equation. So I am using here v equal to u plus at. So vy equal to uy minus gt. I am using that equation because initially the projectile is moving in the upward direction. So compared to the initial case, acceleration is in the downward direction. So minus g, right? So you should consider in this case g with respect to initial velocity. Okay, so vy is equal to uy minus gt. So uy you know, t is also know, g is also know, so you can find out vy. Uy is 250 and g is 9.8 and t is 30. So you will get vy as minus 44, right? Minus 44 meter per second. Got it? Okay. Now if you substitute these values, so velocity is root of vx square plus vy square, right? So vx and vy you already found out. So if you substitute vx and vy in this equation, you will get velocity 435.2 meter per second. Now how will you find out the angle phi? Angle phi is simple, the direction of velocity is simple. Tan phi is vy by vx, right? Vy by vx, vy, you need to take only the magnitude, because I already represent phi in the graph, so you need to take only the magnitude. Okay, so 44 divided by 433, tan inverse of that value, you will get the phi as 5.8 degree. Okay, so it is a very simple question. Try to get these numerical values. Okay, now we will go to the next question. A body is thrown with a velocity of 10 meter per second at an angle of 60 degree to the horizontal. So initial velocity and theta is given, right? If another body B is thrown at an angle of 45 degree to the horizontal, find its velocity if it has A, same horizontal range, B, same maximum height, C, same time of flight as that of body A. Okay, the first body is actually body A. Okay, so for body A, the velocity and angle of projectile is given. For body B, the angle of projection is given 45 degree. You need to find out the velocity of body B for three different cases. What are the three different cases? In case A, both body has same h, sorry, same r. in B same h and C same time of flight. Okay, you got the idea. Now UA is given 10. I am putting UA as the initial velocity of A as UA. Theta A is 60 degree. UB you need to find out UB, and theta B is 45 degree. Okay. Now I am taking the case A. Both the body has same horizontal range, which means horizontal. What is the equation for horizontal range? Range is U square sine 2 theta by G. So both the body has same horizontal range means RA equal to RB, right? Now if I am substituting RA is UA square sine 2 theta A all divided by G equal to UB square into sine 2 theta B divided by G, right? Both body has same range is given in part A. So GG get cancelled. So I will get, if I substitute the value of UA here, 10 square sine 2 into theta A 60 degree equal to UB square into sine 2 into 45 degree, right? So if I rearrange this term, 100 square sine 120 equal to UB square, 2 into 45 is actually 90, so sine 90 is 1. So I will get UB as 9.3 meter per second. Okay, try to get this value, try to solve using calculator. Okay, UB is 9.3 meter per second. This question is very simple. Okay, now we will go to the B, part B. Both have same height. What is the equation for height? Height is U sin theta all square divided by 2G. So HA equal to HB, which means UA sin theta A all square divided by 2G equal to UB sin theta B all square equal divided by 2G. So 2G get cancelled. You will get 10 sin 60 all square equal to UB sin 45 all square. Again square also you can cancel actually. If you don't cancel again we will get the same answer. So if you solve this equation you will get sin 45 is 1 by root 2, square is 1 by 2, then take in the other side 2 into 10 sin 60 the whole square. Now you will get UB as 12.25 meter per second. Okay, it's very straightforward. Now part C. Part C is the time of flight of the both the body are same. So 2u sin theta by g is time of flight. So TA equal to TB. So 2u sin theta by sin 2ua sin theta a by g equal to 2ub sin theta b divided by g. 2 get cancelled, gg get cancelled. So ua is actually 10 sin 60 equal to ub sin 45 degree. So you will get ub as 12.25 meter per second. Okay, so try to get these values. So in this question the only thing is you should know the expression for r, h and t. Okay, if you know that expression you can simply put the values and do the problem here. Okay, now we will solve one more problem and we will wind up this section of projectile motion, and in the next video you will discuss the kinetics of curvilinear translation, and that's all about the module 4. Okay, so the last problem of this video lecture: a pilot of an aeroplane flying horizontally at a height of 2000 meter with a constant speed of 540 km per hour, and he wishes to hit a target on the ground. Okay, at what distance from the target should he release the bomb? He is releasing the bomb, not the missile. Okay, the bomb, in order to hit the target. Okay, at what angle would the target appear to him at that distance or from that distance? Okay, so here given ux, so it is a horizontal projectile motion. Okay, thrown horizontally. So aeroplane is flying at a height of 2000 meter and he is dropping a bomb. So it is the bomb will go a horizontal projectile motion, right? So initial velocity ux equal to u equal to 540 kilometer per hour. So if you convert into meter per second, you have to multiply with the 5 by 18, you will get 150. So at what height is he releasing the bomb? That is h is equal to 2000 meter. So ux equal to u, uy equal to 0, and h is equal to 2000 meter. And here in question we need to find out at what distance from the target should you release, which means you need to find out the value s. Okay, the s, not the arc AB. S you need to find out. Okay, so in order to find out s, you take ay equal to g, the distance from the target the pilot should release the bomb. If you consider the motion in y direction, why you need to consider the motion in y direction here? Why can't you use the motion in x direction and find out s? Okay, if you consider the motion in x direction, x equal to vx into t, right? Vx is always constant, vx is equal to ux is equal to 150, but we don't know the value of time, right? T we don't know. After finding out the time only you can find out s, or the distance from O to B, or s, right? So in order to find out the value of time taken by the bomb to reach from A to B, you are considering the direction in y direction, consider the motion in y direction. Clear? Now if you consider the motion in y direction, uy equal to 0, right? Initial velocity in y direction is equal to 0, and ay equal to plus g, and the distance in y direction, not s, it is actually h. H is equal to y equal to 2000 meter. Sorry, it is not s, that is h. Okay, h is equal to y equal to 2000 meter. So if you use s is equal to ut plus half it square, s is actually 2000 meter, right? So y equal to uyt plus half gyt square. So uy is 0, uy is equal to 0, 0 into t is 0 plus half into g is 9.8 into t square equal to y is 2000, right? Now if you simplify this equation, you will get the value of t as 20.2 second. Okay, t value is 20.2 seconds. Now if you consider the motion in x direction, you will get the value of s. So x is equal to uxt, x is actually s. Okay, s is equal to ux is always constant 150 into t 20.2. So you will get the value of s. Okay, as I discussed previously, you don't have to by heart the equation of motion, sorry, the time of flight, height, range equation for a horizontally thrown projectile. Okay, general projectile motion, you remember the equation of time of flight, height and range. For a horizontal projectile motion, you don't have to remember the equation. You can simply take x direction and y direction motion, and you can simply find out the values of this h and s. Okay, so that's why that way we solve this problem. Okay, so s is equal to 3030 meter. Okay, so the part A, or the first a small portion, sorry, a portion of the question is solved. So at what distance from the target should you release the bomb in order to hit it? And you need to find out what angle would the target appear to him from that distance. Means at the point A, the target at the point B, the aeroplane released the bomb at the point A, and target is at the point B. So from A, at what angle the B is appear to the pilot? So what will be that angle? That angle you need to find out. Sorry, you need to draw a line. You need to draw a line from A to B, and the angle made by that line with the x-axis is the angle you need here, theta. Okay, it is not the theta we used in the derivation. Okay, it is simply another theta. Okay, so that theta is same as the theta here also, right? Complementary theta. Okay, so how will you find out theta? Theta is very simple. Tan theta is equal to h by s. H you know, s you already found out, right? So tan theta is h by s. H is 2000, s is 3030. So theta is tan inverse of that value, which is 33.4 degree. Okay, so that's all about the projectile motion. Okay, there are a lot of problems in the Benjamin textbook. You solve that problems. In this projectile motion, normally they ask simple questions. Okay, so try to solve all the problems, and that's all about the projectile motion. And in the next video lecture, it is kinetics, and we will wind up this module and try to solve maximum problems in the textbook and the PDF attached. Okay, thank you for listening this video. Thank you.